All right, in this video we are going to talk about the dot product. All right, so first, before we need to do that, we need to talk about the angle between two vectors. So when you draw two vectors so that they have the same initial point, the two vectors are going to form an angle in a plane, right? By plane, I mean something that's similar to the coordinate plane that we talked about in Calculus 1 and Calculus 2. So at first, that might be a little bit confusing, so let's take a look at how that would be done. So if I click here, you can see here I have two vectors, a blue one and a green one, and they're drawn so that they don't have the same initial point, right? So if you think about the angle between those two vectors like it is, it's a little bit confusing. So what you would do then is to basically redraw this vector so that they have the same initial point. So let's do that. And so I get that red one. And now, again, if this is new to you, you might say, hey, well, wait a second, isn't that a different vector than this green one right here? Aren't they two different things? And the answer is no, that these are actually equal in terms of vectors, right? If you look at the vectors, I'm not going to go into the numerical details, but if you look, right, it kind of looks like they have the same magnitude, the same length, right, and also the same direction, okay? So that, remember, two vectors are equal if they have the same magnitude and same direction. So basically we can redraw this right over this vector so that it's over here, okay? And then when you redraw that vector so that they have the same initial point, they're going to lie in a plane, and I'm going to show you what that plane looks like here, okay? All right, so you can see I drew the plane that both of these things lie in, both of the vectors lie in. And then what I'm going to do is calculate this angle between those in that plane, just like you would in, say, a two-dimensional setting. All right, and we would take this angle. There's actually two angles here, or actually infinitely many, however you want to think of it, but there's two natural ones. There's one right here, right, between the red and blue vectors, and then there's this angle over here, this sort of outside angle here. But what we're going to do is always take the one that's in between 0 and pi radians. Okay, so it would be this angle right here. All right, so that is the angle between two vectors. All right, and again, we would take that, the angle that's between 0 and pi radians when we do that. All right, so that's that process. So even if the two vectors appear initially like there's no angle between them, that we would go through that process, right? Find a vector that's equal to 1 that has the same initial point, and then those two vectors lie in a plane, and then the idea is a lot more solid from that point on. Okay, so that brings us to the definition of the dot product of two vectors. So if I have a vector u and a vector v, then and theta is the angle between those two vectors, then the dot product of u and v, and that's going to be denoted by a little dot here, the operation. So the dot product of two vectors is the magnitude of the vector u times the magnitude of the vector v times the cosine of the angle between those two vectors, okay? It's very important to note, right, that the dot product of two vectors is not a vector, but it is a scalar. For us, that's just going to be a real number, right? Because the magnitude is a real number, this magnitude is a real number, and then the cosine of the angle is a real number. So we're just it just comes out to be one real number when you multiply that out, okay? All right. And so first we're going to do some easy examples, and then we'll talk about the, what is the dot product, and then a simple way of calculating the dot product. Okay, so let's take a look at this example here. We have a vector u, 1, 0, 0, and a vector v, 0, 1, 0. We want to find the dot product, right, of those two vectors. And so let's take a look at this in a new tab. All right, so the vector u, right, is really the vector I that we talked about, the standard vector I. It points in the positive x direction. It is a unit vector, and the vector v points in the positive y direction. So and we want to calculate u dot v, right? And so we know that the dot product, right, is the magnitude of the vector u times the magnitude of the vector v times the cosine of the angle between. The problem with this definition of the dot product is sometimes you don't know what the cosine of theta is, and that might be difficult to find. We will use another definition later that's a little bit easier to calculate with. But for the time being, right, what we can do is just kind of look at this, and we know that the angle between these two vectors, right, because these two vectors are really nice, and it's really pretty easy to tell, right, that the angle between those two would be pi over 2, okay? So in this case, we would calculate the magnitude of the vector u. We know that the vector u is going to be 1, 0, 0, right? And so the magnitude of that vector is going to be the square root of 1 squared plus 0 squared plus 0 squared, and that's going to come out to be 1. We know that the vector v is 0, 1, 0, and so the magnitude of the vector v is also going to be 1. And in this case, because the situation with the two vectors, right, we know that the angle between them is going to be pi over 2, and so this is going to be 1, this is going to be 1, and this is going to be the cosine of pi over 2. All right, and so that's going to be 1 times 0, and that's going to come out to be 0 in that case. All right, so the dot product of these two vectors is equal to 0. Okay, so that leads us to a really important concept, and that is the concept of orthogonality. And in general, if the angle between the two vectors is equal to pi over 2, then the dot product of the two vectors is going to be 0. Okay, just like we saw here. It really, the magnitude of u could be whatever, the magnitude of v could be whatever, but if the angle between those two things is a 90-degree angle, right, a right angle, or pi over 2 radians, right, then the cosine of that is going to be equal to 0. And so the dot product will come out to be 0 in that case. Okay. So, and likewise, right, if the dot product of two vectors is equal to 0, and here we're talking about non-zero vectors, right, then the angle between the two vectors must be equal to pi over 2. Now, if one of the vectors is equal to 0, and I should have qualified that in my notes there, then, you know, if one of these is the 0 vector, then you can get a 0 here. So that's sort of an edge case, but if I have two non-zero vectors, the only way that the dot product could come out to be 0, right, is if the angle between those two vectors is pi over 2 radians. So we are going to say that two vectors are orthogonal if their dot product is equal to 0. So orthogonal, for right now, you can just kind of think of that as as being perpendicular, being at a right angle with each other, but really it's this term is used in more general situations than the term perpendicular. here, but I'll leave that for another class in linear algebra to talk about. All right, so the next example for the dot product, right, is this one. We want to find if the vector u is equal to the vector 3, 0, 1. What we want to do is find u dotted with itself. Okay. All right, so the formula would be, for the dot product, would be the magnitude of the vector u, the magnitude of the first one, times the magnitude of the second one, which happens to be the same, times the cosine of the angle between those two vectors. Okay. So first, let's find the magnitude of u. So the magnitude of u, that would be the square root of 3 squared plus 0 squared plus 1 squared. And that's going to come out to be 10. When we do that. So this is going to be square root 10 times square root 10 times the cosine of the angle between the two vectors. So in this case, right, you might say, well, two vectors, there's just one vector, right? And so in this case, the angle between those two vectors is going to be 0, right? Because it's the same vector itself. So this is going to be the cosine of 0 radians, right? And the cosine of 0 radians is 1. All right, so in this case, we just basically get, since this comes out to be equal to 1, we just get the length times itself, or the length squared, right? And so that's going to come out to be equal to 10 in that case. All right. And again, this situation, it was pretty easy to find the cosine of the angle, right? Because it's the same vector, so the angle had to be 0. All right. And so in other situations, it might not be so easy to find what the angle between the two vectors is. So we would are going to take a different approach in the long run to calculating the dot product, an easier approach actually. All right, that brings us to another important fact, and that is if you take the dot product of a vector with itself, like we just did, then what you wind up with is the magnitude of the vector squared. That's what it's going to be equal to. Okay. And again, you can see it's pretty straightforward because whatever vector you have here, right, if it's the same vector, the cosine of the angle between those two vectors is going to be equal to 1 because the angle between them is 0 radians, and so the cosine of 0 radians is equal to 1. So you just wind up with the magnitude of the vector times itself. All right, so that's an important fact that we need to know. Okay, so in the next video, we are going to talk about the orthogonal projection, and this is one of the things that will lead us to what exactly the dot product is geometrically. Okay.